Dear students, yesterday we discussed the Rolle's theorem. Today we shall discuss the extended version of that very theorem, which is called the mean value theorem, or also called as Lagrange's mean value theorem or first mean value theorem. So the statement for this theorem is: let f from closed interval a to b to r be a function with the property is that f should be continuous on this closed interval ab, f is differentiable on this open interval ab, then according to mean value theorem there exists a point c belongs to this open interval ab such that f dash of c equals to f of b minus f of a upon b minus a. So this means that if f from closed interval a to b be a continuous and a differentiable function on it, then there exists a point within this interval such that the derivative at that point equals to f of b minus f of a upon b minus a. Now let we consider the graph of the continuous as well as the differentiable function. Here this is the graph starting from point a to b. It is a graph, it is continuous because there is no break in this graph. Also it is differentiable at point it is differentiable on open interval ab because there does not exist any peak or any edge on this graph, so it is differentiable within this ab. Now here we have point a, so this means that corresponding point on this graph is a whose coordinates are a f of a, because this a is the point on plane and any point on plane is of the form of xy. Here a represents the point on x-axis and corresponding y is f of a. Similarly, endpoint at endpoint x equals to b, we have point b whose coordinates are b f of b. Now when we join this a and b, it is a straight line. Now let's see the point within this b, ab. Then at x equals to c, we have a tangent, this tangent. At x equals to c to this curve. Now here this tangent is parallel to this line AB, which implies that when lines are parallel implies that their slopes are equal. Hence the slope of this tangent equals to the slope of this line segment. Now slope of the line segment, that is AB with endpoints a f of a, b f of b, is given by the difference of this y coordinates upon the difference of x coordinates, that is f of b minus f of a upon b minus a. Also the slope of the tangent at x equals to c by the definition of derivative is f dash of c. Now here this line AB and this this tangent at x equals to c are parallel, which implies that their slopes are equal. So this means that f dash of c equals to f of b minus f of a upon b minus a. So this means this is the Lagrange's mean value theorem or the first mean value theorem or simply mean value theorem. Now if f of b equals to f of a, which implies that when we substitute here, it is f dash of c equals to 0, which is nothing but it is Rolle's theorem. So simply this theorem is generalization or extended version of Rolle's theorem. We cannot apply this theorem to the functions which are not continuous or which are not differentiable. Like if we consider a function f of x equals to x square plus 6x plus 2 on interval 2 5, closed interval 2 5, we have to verify the mean value theorem. Now since f of x equals to x square plus 6x plus 2 is polynomial, and we know that the polynomials are continuous as well as differentiable on at any x, hence we can apply the mean value theorem or mean value theorem is applicable. So this means that by this theorem there exists a point c in this interval, that is 2 5, open interval 2 5 such that f dash of c equals to f of 5 minus f of 2 upon 5 minus 2, that is f of 5 minus f of 2 upon 3. So name it equation first. Given f of x is here x square plus 6x plus 2, which implies that f dash of x is 2x plus c, which implies that f dash of c equals to 2c plus 6, because by substituting x in this derivative. Also f of 2 by substituting x equals to 2 in given function we get 18, and f of 5 by substituting the value of x equals to 5 in given function we get 57. So substituting f dash of c, f of 2, f of 5 in given equation, which implies that f dash of c equals to f of 5 minus f of 2 upon 3, which is 2c plus 6 equals to 39 by 3, which is 13. Hence 2c equals to 7, or c equals to 7 by 2, which is 3.5. Here this 3.5 lies in this interval 2 5. So this means that there exists a point c between 2 and 5 such that f dash of c equals to f of 5 minus f of 2 upon 5 minus 2. So in this case this Rolle's theorem is mean value theorem is applicable. Hence there exists a point c within the interval such that f dash of c equals to f of 5 minus f of 2 upon 5 minus 2. Now if we consider another function like f of x equals to greatest integer function, where the domain of the function is closed interval 2 5. Here greatest integer function in this interval 2 5, 2 3 4 5 are the integers, and you know that at the integral values this greatest integer function is not differentiable, hence it is not continuous at these points. So when it is not differentiable, it is not continuous, which implies that we cannot apply mean value theorem to greatest integer function. In this was the last topic of this chapter. So inshallah tomorrow we will start a new chapter, that is applications of derivative. So thank you.